Okay, so let's interpret key features of a quadratic function. And so I have here three different quadratic functions, and we want to know the domain, the range, the x-intercepts or zeros or the roots. It's the same thing. The y-intercept, the axis of symmetry, and the vertex. And we want to know where it's increasing, where it's decreasing, positive, negative, and the end behavior. So it's a lot of different things that we're going to go over. So let's start with the domain. The domain for all functions, if there's no constraints, and there are none here, is all real numbers. So we can just write a or n for that. The range is going to be we use our vertex right here to determine our range. And the range is all the y values. And if it's a minimum, so it's going up, it's going to be greater than this y value here at -4. So we're going to write greater than or equal to -4. The x-intercepts are very easy. It's where it crosses the x-axis. That's at -4 and 0. The y-intercept, we can see that it is the origin. So our y-intercept is also 0 or 0, 0. The axis of symmetry, it goes through the -2. It's the x value of -2. And the vertex is this little point that I put here. This is -2, -4. Okay, where the function is increasing is everything to the right of the axis of symmetry, because it's decreasing, decreasing, decreasing from left to right, and then it changes direction, starts increasing. So it's x is greater than or equal to -2, and it's decreasing everywhere to the left. X is less than or equal to -2. Where the function is positive, it's everywhere above -4 and 0. So I would write x is less than or equal to -4, comma, x is greater than or equal to 0. Those are the two spots that it's increasing. It's negative between -4 and 0. So I'd write -4 is less than or equal to x is less than or equal to 0. And finally, the end behavior, it's very easy. You just got to know what the graph looks like. If it's a smiley face, they're increasing whether you go to the left or the right. It's just the notation is a little bit weird. So if you're going up from, as you go to the left, you would say it would be as x approaches -infinity, f of x approaches infinity. So this says as you go to the left, you're going up for forever. And then we also need to state as you go to the right. So what's my end behavior as I go to the end? This is going up for forever as we go to the right. So as I say, as x approaches positive infinity, f of x also approaches positive infinity. Okay, so we're just going to do the same thing for these other guys just so you can see if there's anything that might be different. So the domain, again, is all real numbers. It's a function. The range is everything greater than my minimum value here is at -8. So I say y is greater than or equal to -8. My two zeros, one is 0 and one is 8. My y-intercept is at 0 once again. My axis of symmetry is at +4. My vertex is 4, -8. It's increasing everywhere to the right of 4. So x is greater than or equal to 4. It's decreasing everywhere to the left of 4. X is less than or equal to 4. It's positive left of 0 and right of 8. We can see that here. Below here is negative, above here is positive. So x is less or equal to 0. X is greater than or equal to 8. It's negative between 0 and 8, just this little section here. So I'd say 0 is less than or equal to x is less than or equal to 8. And my end behavior, once again, it's going up on both sides. So we'd write the same thing as over here. As x goes to the left toward -infinity, f of x or y, same thing, approaches infinity. And as x goes to the right toward positive infinity, f of x approaches negative infinity, or it goes up again, positive infinity again. So both of these need to be positive infinity because they're going up on both. The opposite of our last one. So we can see that this guy is going down whether you go to the left or the right. The domain is still all real numbers. The range is everything less than my max value here. It's a max now because it's got a sad face, so it has a max, and then my range is less than that, so that's at 0. Y is less than or equal to 0. My x-intercept, there's just 1, that's at -2. My y-intercept is also at -2, crosses the y-axis at -2. My axis of symmetry is also at -2, it's going straight down at -2. My vertex is -2, 0, because we're not going up or down to get to your vertex. It is increasing everywhere below 0. Actually, it's never increasing. What am I talking about? Or wait, I'm thinking positive. It's increasing to the left of -2. X is less than or equal to -2. It's decreasing to the right of -2. X is greater than or equal to -2. It's never positive is what I meant to say. It's never above this 0, so I'm right never. It would be negative for all real numbers. No matter what it is, it's going to be a negative number. Real numbers. And then now for the end behavior, it's just this notation that looks a little weird, so it's just about knowing the notation. As x approaches negative infinity, f of x also approaches negative infinity. So this means as we go left, we're going down. And then as we go right, as x approaches positive infinity, f of x approaches positive infinity as well. As we go to the right, I'm sorry, I said positive infinity, negative infinity. So they're both negative infinity. So don't get messed up here. I mean, it's just the notation. If you can see that it's going down, you would write negative infinity for as it approaches. If you can see that it's going up, it's approaching positive infinity.